In example 4, we're comparing median home values. So the median home values for two regions are provided below. Assume the house values are changing linearly, meaning we have a constant rate of change. We can use linear models to model this change, model this behavior. We want to construct a function f of time t in years for region 1 and a function g for region 2 that model this scenario. And then we're given an important piece of information here. We want to let the year 2000 be a time of t equals 0. That means our years will get updated. 2018 is 18 years since the year 2000. 2022 is 22 years. So when we look at constructing our models, we'll modify our independent variable, our t values. And then we'll look at our two values for region 1 to construct f of t, and our two values for region 2 to construct g of t. Essentially, we have two coordinate pairs for each of these models. So using Wolfram Alpha, we'll construct a line through those two results, through 18, which represents the year 2018, and 265,629.34, and 22, 299, 874.78. And we generate that linear model in slope-intercept form. We would do exactly the same thing. We would still use 18 and 22 as our independent values, our x values. And then for our y values, we would replace the two values we just used with the values for region 2. And we would similarly generate the model 861.462t plus 260,300. In part B, we're asked in which region have home values increased at a higher rate. Rate refers to the slope, how quickly it's changing. Comparing our two slopes, we can see that f of t has the larger slope. Meaning it has the higher rate of change. And that tells us that home values have been increasing or have increased at a higher rate in region 1. Because that slope is larger, the change is larger, the rate of change is larger, so we're seeing f of t grow faster, meaning median home value in region 1 is growing faster. Then we want to use our models in part A to predict the median home value for each region in 2028. Still, we're using 2000 as year 0, so what we'll actually plug in is a value of 28 into each model. We could then plug those models into Wolfram Alpha, substituting in 28 for our value t, and we would get for f of 28, $351,243.08, and for g of 28, we would get $284,420.94 as that median home value. In part D, we're told that assuming this linear trend has been consistent over time, meaning we can use it to predict future or past values, We can use our models from part A to determine the year when the median home values in these two regions will be or were equal. That tells us we would solve these two equations set equal to each other. So we would type in our function f of t set equal to our function g of t in Wolfram alpha. Solving should give you a value of 19.322, or rounded to the nearest whole number would be 19. But keep in mind that value for t is years since 2000, since that was our 0 year. So what this is really telling us is that in the year 2019, that's when the median home values in these two regions were equal.